So this example reads, a zip code is made up of 5 numbers. How many possible zip codes are there? I'm going to approach this problem using the task method. And typically when you see counting problems that involve zip codes or social security numbers or some series of letters and numbers, the task method is the best way to do this. So here we go. Here are my 5 tasks. Now the 5 tasks are going to correspond to the 5 numbers that you choose. So the first task is going to say pick the first number, right? And so the question is how many choices do you have for that first number? Well, how many digits are there? We can start with 1 through 9, but don't forget there's always 0 also, which means that there are 10 digits in total. That's the first task. The second task would be pick your second number. And again, there are 10 different options. And the reason that there are 10 different options is because there's no restriction on the numbers that we are given. It just says pick 5 numbers. So we're going to then pick our third number and our fourth and our fifth. Those are our 5 tasks. Each of those has 10 possibilities. And remember that when you have your tasks, you always multiply the numbers in between them, which leaves me with 3, 4, 5, 100,000 different possibilities. Now this works nicely, and it works again because of the fact that there are no restrictions on the numbers that we put in our zip codes. So let's take a look at another example of this where we're going to throw a restriction in there. So now this next one says if the first number can't be a 0. So again, our 5 tasks are the same, 1, 2, 3, 4, 5, picking your 5 numbers. Well, the first one can't be a 0, which means we really can only pick the numbers 1 through 9, and so there are 9 different options for the first number. Now notice this restriction is only on the first number. It's not on the other numbers, so all of the other numbers have the possibility of 10 choices. And so we get, when we multiply, 90,000 different possibilities. Let's try another one. Now this next one reads that none of the digits can be even. So if we take our 5 tasks again, so this is a different option. Now none of these digits can be even. Sometimes in these examples, the best thing to do is just to list out your choices. So if none of the digits can be even, we're talking about 1, 3, 5, 7, and 9. 0 is considered an even number because it's divisible by 2, which means that there are 5 choices for each of these tasks because none of the digits can be even. So as you can see, what we're doing every time is we are actually just looking at what the specific restrictions are and applying them to the particular problem. And so we get 3125 as our last answer.